Well, back to Hurricane Melissa. It is now tracking over Jamaica, expected to impact Cuba in the next several hours before then reaching the central Bahamas on Wednesday. CNN meteorologist Chris Warren joins me now. And Chris, you're the expert, but when I look at these numbers, minimum pressure of 901 millibars, lower than Hurricane Katrina during its peak low pressure back 20 some odd years ago, and these winds 185 miles per hour. I mean, that's a pretty incredible combination.
It is. Now, every storm is different. So some of these storms can be intense, but not very large. So really packing a huge punch like a bowling ball, but not large like a beach ball, which might not be as tense and as powerful. But in this case, yes, both of those storms are extremely strong at their peaks. And this one now is down to a Category 4 hurricane, which still, Jim, has the potential for catastrophic damage. Now, another thing, these winds, the gusts that are still possible, up to 220 miles an hour, are reserved for a very small location right there, right next to the eye. Hurricane force winds, you're looking at 75 miles an hour, stronger. Outside of that, certainly still a possibility. And these frequent gusts still what is within the realm of possibilities here. In fact, the winds have gone up a bit here in Kingston, gusting to almost 50 miles an hour. But this right here, where it made landfall, right near New Hope, has now moved across the western part of the island near Montego Bay, where surge is still a possibility and the flooding is still there. Still a chance for flash flooding, mudslides, and landslides. The storm did come on shore right here. And also another aspect with hurricanes, the winds over water push that water, the seawater, toward land. Now there's that counterclockwise swirl, so you're going to get the water going up like this, the salt water, while the fresh water from the rain is trying to get out. So that's another concern that we're watching as Hurricane Melissa moves offshore on the north side of Jamaica. The winds are turning direction now, so the surge coming in this way in Montego Bay is also something that is of concern. Now, the rainfall is decreasing. So we've already seen a lot of rain in Jamaica, but the storm is now getting into, for Jamaica, and as far as the weather's concerned, essentially into like the fourth quarter or the last chapter, if this was a book, if the story for Jamaica was a book, in terms of the weather. Now, there's going to be a whole nother book written on the recovery in Jamaica, so a whole different deal here. Montego Bay, wind still, hurricane force potential, and then it is going to be tonight into tomorrow for Cuba with very strong winds there. And then, Jim, also going to see the potential for a Category 2 hurricane impacting the Bahamas.
Chris Warren, thanks so much for tracking it for us. Joining us now, Michael Fischer, assistant professor at the Rosenstiel Hurricane Hub at the University of Miami, and he joins me now. Michael, I wonder if I could ask you a similar question I asked our meteorologist there, but that combination of low pressure on a scale of Katrina and just crazy high winds, as I understand it, the second strongest storm ever tracked in the Atlantic. How do we get here for a storm this size and this intensity?
It's a great question. I'm sure it's going to be subject of many studies going forward. To get a storm this intense, we need some ingredients in place, and we had all of those. Namely, we need very warm sea surface temperatures, and also that warm water needs to extend to a deep layer beneath the surface of the ocean. We had that in place, and we also had favorable environmental winds and a moist enough atmosphere. So we had all the ingredients in place to create a monstrous storm.
Let me ask you this, because when we get into hurricane season, I will often ask our meteorologists, or they will make the point that as the hurricanes approach the shore, they get into shallower waters. Those waters are particularly warm, and we should note that the temperatures in the Caribbean are breaking records this season, that leads to, for a lot of these storms, this kind of last-minute intensification that makes them even more damaging than they might have been otherwise. Do I have that right?
You're correct that the warm water is extended all the way up into the coast. And so a unique aspect about Melissa's intensification is that it continued to intensify all the way to the coastline. Normally, we sometimes see these storms when they get to Category 4, Category 5 strength kind of oscillate in strength. They go through some internal processes that can result in temporary weakening of the winds. But in Melissa's case, it had a very resilient inner core that continued to intensify all the way up until landfall, which is, of course, incredibly unfortunate for those in the path of the storm.
Let me ask you this, because it's a big picture question. given climate change and increasing temperatures, including water temperatures around the globe, is there an element, I know no particular storm can be tied to climate change, but the broader conditions can, I imagine, increase the intensity of storms, et cetera, across the board. Is that a possible component to a storm of this size and this intensity?
Yeah, that's a great question. I think anytime you increase the sea surface temperatures, you're effectively raising the ceiling of how strong these storms can get and how quickly they can intensify. And so, to that respect, we essentially have a storm in warmer than average waters, up to 30, 31 degrees Celsius. And so that has a very high ceiling. And unfortunately, that ceiling was essentially realized by Melissa. And so, if we continue to see sea surface temperatures increase, it's quite possible that we can continue to see storms reach this intensity potentially more often, or maybe even stronger storms potentially. So that's definitely something we're going to have to monitor going forward.
Does the early warning system for storms match that new dynamic? Right? Is it able to measure in the time necessary so that folks like you and, well, governments in Jamaica, relief organizations, et cetera, know in time about the intensity of storms?
Yeah, so this is a very significant forecasting challenge. So when hurricanes strengthen very rapidly, these periods tend to be associated with unusually large forecast errors. And so if we have conditions in place that make these rapid intensification events more common, or storms intensify at greater rates, this is likely going to make the forecast more challenging as well. In the case of Melissa, thankfully, our computer model guidance in the National Hurricane Center had a really good handle that this rapid intensification event was going to take place. And so Jamaica was under a hurricane watch for multiple days before the landfall today. And so in this case, we had pretty good warning, but it's possible that we might have some storms that sneak up on us more quickly in the future. So it's going to be a very significant forecasting challenge. Hopefully we can make some progress on going forward.
Michael Fischer, thanks so much for helping us understand.
Thank you.